Practice problem number 1, skeleton equation, reaction between hydrogen and oxygen. Well, hydrogen, we know, is a diatomic substance, so that's going to be H2. And it's going to react with some oxygen. Oxygen is diatomic, so it's going to double up, O2. And it's producing water. And of course, water is H2O. Since to write a skeleton equation, we don't need to balance it. That's number 1. Number 2, we have some iron 2 sulfide. Iron is Fe. The charge is given. The Roman numeral 2 tells us it's a 2 charge. Sulfide is sulfur as an ion. It's group 6. Group 6 wants to gain 2 electrons. So if we crisscross that, the 2's go to the bottom, we reduce it down, and we end up with iron sulfide. But this tells us it's producing that. So that means that's actually a product. It's being produced. So they've worded it backwards. Okay, we're getting that from iron and sulfur. So there's a skeleton equation. Iron and sulfur produce iron sulfide. Number 3, skeleton equation representing the heating of magnesium carbonate to produce solid magnesium oxide. So we're going to heat some magnesium carbonate. Carbonate is a polyatomic, CO3. We look it up on page 257. And then we're going to crisscross the charges. The charge of carbonate is given to us as 2 minus. Magnesium is group 2, so it's 2 plus. And if we crisscross the charges, 2 goes down there, and the other 2 goes down there. Now, since we have 2 2's, we're going to reduce it down. So that's the same as 1 to 1. So essentially, we'll just get rid of those 2's. Okay? So there's our magnesium carbonate. Says it's going to produce solid magnesium oxide. Now, for magnesium oxide, we have some magnesium, which is group 2. We have some oxygen, which is group 6. Group 6 is going to lose 2 electrons, or gain 2 electrons rather. And if we crisscross the charges, and then again, a 2 to 2 ratio is the same as 1 to 1. So we're going to reduce that down. And we get some carbon dioxide. Okay, if there's a prefix, that's a molecule. So carbon, there's no prefix, that means there's 1. And oxide, di means 2, so I have 2 oxygens. All right, and that is my skeleton equation for that one. All right, number 4 says a balanced equation for the production of HCl gas. Okay, so I'm producing HCl. That formula is given to me. Well, what did it come from? Well, I must have had some hydrogen, and I must have had some chlorine. Okay, both of those guys are diatomics. Hydrogen is doubled, chlorine is doubled. We've memorized those. That's how we know there's 2 of them. There's a skeleton equation. So once I have my skeleton equation, I'm going to bracket those guys. Can't change those subscripts anymore. Once I know the proper formulas, I cannot change the subscripts. So I'm just going to total up what I have on each side. So on the left side, I have 2 hydrogens. On the right side, or the left side, I have 2 chlorines. The right side, I have 1 hydrogen and 1 chlorine. So I have twice as many on the left side. That means I need to double up the right side. So I'm going to put a coefficient in front of there. Now I have 2 hydrogens and 2 chlorines. And now that's balanced. All right, number 5 says write a sentence. So we're just going to interpret that if we were, what would it say if we were reading it? So we could say we have some hydrochloric acid, or hydrogen chloride, if you will, and that's going to combine with some calcium carbonate, and it's going to produce some carbon dioxide gas, some calcium chloride in an aqueous solution, and some water. Number 6, we have some silver, solid silver, combining with some solid sulfur and producing some silver sulfide. And that is already balanced. Number 7, we have some some sulfuric acid. Now, any acids, I will give you the formulas. You don't have to know how to write those formulas. That's H2SO4. We're forming, that's a formation of sulfuric acid. So that means actually sulfuric acid is being produced. So we're actually going to put it on the right-hand side. Okay, the problem says we're making that. And we're making that from water. Water, of course, is H2O. And we're adding some sulfur trioxide. So sulfur, there's no prefix, so it's just singular. And oxide has a tri, so tri means 3. All right, there's my skeleton equation. Once I do that, I'm going to lock these guys in. I don't want to change the subscripts. I can only change the coefficients. All right, I'm just going to summarize what I have on the left. I've got some hydrogen. I have 2 of them. I'll have some oxygen. I have 1 oxygen plus 3. That's 4. And sulfur, I have 1. On the right side, I have hydrogen. I'm going to keep them in the same order that I put over here. HOS, HOS. Okay, I have 2 hydrogens. I have 1 sulfur. And I have 4 oxygens. All right? Oh, that's already balanced. So I'm done. How about that? All right, number 8, a balanced equation from this word equation. So my first step is to write my formulas. I have some silver nitrate. Okay, silver is a +1 charge. You don't need to know that. I will tell you that on a test. Nitrate, we looked that up on page 257 to get the formula. It has a -1 charge. So if we're going to crisscross the charges, it's just 1-to-1 ratio. We're going to combine it with some copper metal. I'll just do it right here, I guess. That's just a pure element. And that's going to produce some silver and some copper nitrate. So copper nitrate, again, my polyatomic formula is the same, and my copper has a 1+ charge. And we crisscross the charges. Okay? There's my skeleton equation. And that's actually balanced. I don't have to do anything with that. All right, number 9. Balanced equation. I have some phosphorus, some oxygen. Oxygen is diatomic. We have that memorized. Tetraphosphorus. Okay, so that tells me I have some phosphorus. The tetra tells me how many. There's 4. Decoxide. Oxygen. Deca is 10. There's my formula. Once I have the formulas, I'm going to lock them in. Can't change the subscripts anymore. Can't change subscripts to balance. All right, then I'm going to sum up what I have. Well, over here, I have phosphorus. I have 1 phosphorus. And oxygen, I have 2 oxygens. Over on the right side, I have phosphorus. I have 4 phosphorus. And oxygens, I have 10 oxygens. I'm going to start with my phosphorus. It probably doesn't matter the order I go in here. I need 4 phosphorus on the left side. So I'm going to put a coefficient in front. Now I have 4 phosphorus. And I'm going to put a coefficient in front of oxygen. Now I have 5 times 2, 10 oxygen. And that's balanced. And we're done with section 11.1.